Hello everyone. What we're about to do is a concept that's kind of hard to do without drawing. Okay, it's kind of hard to, even in a traditional classroom, we're going to, it's going to be a concept that you really have to really concentrate on. And it's because it's a different way of graphing. And what we're going to be doing, we're going to start off with section 3.1, which is the basic graphs. Okay? Now, first of all, y equals sine x. The most basic function we have so far, id and cosine x. But you ask yourself, how do we determine what the graph of y equals sine x is? Well, think about this. Let's look at the unit circle. Okay, so we have the unit circle here, and here is the point 1, 0. This is the point 0, 1. This is the point -1, 0. And this is the point 0, -1. And we know these better as 0 or 2 pi, pi over 2, pi, 3 pi over 2. Okay, so this is our unit circle. So if we're thinking in terms of a graph, think about how you used to graph something like y equals x plus 1. You would determine the x coordinates, 1, 2, and 3, and then you would plug them in to get the y coordinates, right? Well, this is the same thing here. You determine your x's, which in this case x can be anything for sine, because when we start talking about sine x, you've got to think about what your domain is here. And as you go around this unit circle, sine is going to be defined everywhere. There is not a point on here that if I asked you on the unit circle what is sine of that particular point, and that you couldn't give me some kind of number. Okay, so sine is the domain of sine is going to be negative infinity to infinity. Okay, negative infinity to infinity. Now, think of what we're trying to decide what the graph of sine x looks like. Well, remember what sine is. Sine of x is the same thing as b of our point AB. If you remember back when we were studying the points, sine was the b coordinate, and cosine was the a coordinate. Well, sine is the same thing as b. So if we're in quadrant 1 here, if you're looking at quadrant 1, what is sine doing? Well, the smallest it is 0 at this point here, and the largest it is 1. So sine increases from 0 to 1 as we go this way. All right, look here. Sine decreases from 1 to 0 in quadrant 2. Okay, it decreases from 1 to 0, from pi over 2 to pi. Well, in quadrant 3, from pi to 3 pi over 2, sine goes from 0 to -1, so it decreases again. And then from 3 pi over 2 to 2 pi, sine increases from -1 to 0 on the unit circle. Now, why is that going to be helpful? Because decreasing and increasing are going to be a lot of how we think of the sine and cosine functions when we get ready to graph them. Okay, so we studied last section, we said that sine and cosine were something called periodic functions. We said they were periodic. And we said that the period of these were 2 pi. And we gave the reasoning that it takes after one full revolution of the unit circle, we are now back at where we started, and we're getting the same answers over again, the same points over again. So it makes it a periodic function. So here's how I want you to begin to learn how to graph these. Okay. So first and foremost, we have y equals sine x. That's what we're going to try to graph. So think of your y-axis and your x-axis. Okay, what is the most that sine can be? Well, the largest number we showed on our unit circle that sine could be was 1. And the smallest number was negative 1. Okay, that works with sine and cosine. The largest number can be 1. The smallest number can be negative 1. Now, let's think about our x values. What do we look like here? Well, we go from 0 to pi over 2 to pi to 3 pi over 2 to 2 pi. Now, what we would call this, we would say that this is one period. One period, okay? From 0 to 2 pi, 0 to 2 pi, that is one period of the sine function, okay? So now we have to determine what our graph looks like at these x coordinates. Now you're going to have to get used to it. There will be some that have numbers to them, and we'll do an example of that. But most of them your x coordinates are going to be in terms of 0, pi over 2, pi, 3 pi over 2, 2 pi, things like that. Okay, so let's not get ahead of ourselves. So at 0, think of your unit circle again. Let me draw it over here. Think of your unit circle. At 0, what is the sine of 0? Well, 0 is right here, so the sine of 0 is 0. Now notice, that's an x-intercept there. That is an x-intercept. All right, what's the sine of pi over 2 as we go this way? Well, the sine of pi over 2, remember we said is 1. So the sine of pi over 2 is 1. All right, what about pi? Well, the sine of pi, we go from 1 down to 0, remember? So that is, the sine of pi is going to be 0. Now we're going based on these points here. Notice, this is the point for pi, and the sine part of the point is 0. Okay? What about 3 pi over 2? Remember what our graph does. We go from, sine goes from 0 to what? What is this point here? This is the point 0, negative 1, or 3 pi over 2. Well, what is the sine of 3 pi over 2? Well, it's negative 1. So we go down to negative 1. And finally, what's the sine of 2 pi? Well, that's us coming all the way back around to where we started. And we started at this point here. So the sine would be 0. Sine is the b coordinate, remember. Okay, so here is our sine function. And you'll be able to draw yours better than I will. But this is our sine function. Now, because this is a periodic function, what I can tell you very easily is that if we extended this on out, because there's an x-intercept at pi, notice every pi there's an x-intercept. 0, pi, pi over 2, there's an x-intercept. So there would be an x-intercept at 3 pi and at 4 pi. So because this is a periodic function, it's going to behave the same way. So we'll go up, down, back up again. And now it doesn't matter what direction we go. if we go negative pi, negative 2 pi, okay, it's just going to go in almost a reverse fashion. So it goes like this, so to speak, okay? Now, this is, notice it looks like a wave, looks like a heart monitor. This is what we call a sine wave, okay? So notice sine, notice where it started. We started at 0 at the x-intercept, and then we ended at the x-intercept of 2 pi, okay? So this is how to graph sine. So we say that the range of sine is from -1 to 1. Remember the domain? See how it continues? I mean, this sine wave continues into infinity and negative infinity in both directions, oscillating. We call this, every time we go from here to here, we call this an oscillation, okay? So it's oscillating back and forth, all the way until we get to infinity or negative infinity. Okay, and so we said the period was what again? The period is 2 pi. The period is 2 pi. So now the period for sine and cosine is going to be one and the same. So let's think about cosine here. Looking at our unit circle here. Notice what cosine would be our x-coordinate. We go from, and this is the point 0, 1. Cosine goes from 1 to 0, 0 to -1, -1 to 0, 0 to 1. Okay? Notice how we're doing that up down motion here. That's what the graph of cosine is going to look like. So let's look at the graph of cosine and see how to do this. So y equals cosine x. Okay, again, the range is going to be the same. It's going to be from -1 to 1. So when you draw your graph out, you can go ahead, -1 to 1. And same kind of period. It's going to have a period of 2 pi. So we can start with 0, pi over 2, pi, 3 pi over 2, 2 pi. And then, so let's think about what cosine is doing here. And if you need to make yourself a t-chart as you do this, by all means, go ahead and do it. It will be fine. But so that you can see what this is doing. So let's not use this right here. Let's use a t-chart. So what is the cosine of 0 on your unit circle? I should have drawn that unit circle anyway. Think of your unit circle. What is the cosine at 0? Well, hopefully you've learned your unit circle and you know that's 1 because the x-coordinate is 1 at that point. What about pi over 2? Well, hopefully you know cosine here. The x-coordinate at this point is going to be 0. What about pi? Well, the x-coordinate at pi is -1, if you remember. And then, what about 3 pi over 2? Well, the x-coordinate there is going to be 0. And what about 2 pi? Well, we're back around to where we started, so the x-coordinate is going to be 1 again. So you can make yourself a t-chart and do it like that and then transfer it to the graph. So 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, 2 pi, 1. Now, notice the difference here. With the sine graph, where did we start? We started right here at 0 at the x-axis. But notice where the cosine graph starts. It starts up on the y-axis at 1. Okay, so that make sure you're picking up on these noticeable differences in sine and cosine. Okay, noticeable differences. So this is what our cosine graph looks like over the period of 2 pi. Now, think about this. We have an x-intercept at pi over 2 and 3 pi over 2. So notice what we're doing. What that means is, if you're thinking about it in terms of where's the x-intercept? Well, it's every pi units again. So what would be the next x-intercept? Well, pi over 2, 3 pi over 2, 5 pi over 2. Then you have 3 pi. So the next x-intercept, this is the next intercept, so the next x-intercept is going to be at 7 pi over 2. And then here's 4 pi. So here's the next period in our graph. Okay? So we could extend this, and it continues our whole period here. It's going to look the same again. Notice the wave looks completely the same. We just extended it. And the same thing works if we go in the other direction. If we went negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay? We're still going to cross the axis at the pi over 2's. Okay? We're still, our x-intercept here is still occurring at the pi over 2's. So as you're graphing this, you need to start recognizing some different features. Details are going to be the difference in you getting these right or wrong. You need to be able to look at these graphs and say, all right, cosine starts up here at 1 right here, but sine starts down here at 0. Okay, so if we were to graph sine and cosine on the same graph, so if I just go in here and I add sine to this graph, here's sine. Okay, so you can see the difference. Sine starts at 0, cosine starts at 1 on the y-axis. And be able to recognize that. Be able to recognize where the x-intercepts are, where the y-intercepts are. Be able to recognize where the high points are. Now, we call these high points altitude, but we'll talk about that later. Be able to recognize where the high points are, how it's oscillating. You should be able to recognize symmetry, how it's looking symmetrical in certain areas. Okay, so keep that in mind. Now, homework with this is going to be kind of weird, okay? Unfortunately, it's the best way you can do it online, but it boils down to this. How are you going to see this on an exam? I'm going to expect you to be able to graph, just like we've done here. Draw me the graph, just like we did here. No matter what, no matter how I have to word it on homework, because it's hard to draw a graph on the computer and that sort of thing. No matter how I have to word it to assess you on homework or quizzes, it boils down to you being able to graph it for me. And that's what you're going to have to do. So practice problems in the book that ask you to graph them, okay, in section 3.1 and 3.2. Please do that. All right, so this is the first video of section 3.1. We'll come back with tangent and cotangent.